Welcome to the fascinating world of logarithms. Today, we're diving into how to rewrite logarithms with different bases, enhancing our mathematical toolkit. First up, let's tackle a common scenario. Most calculators are equipped with keys for common logarithms and natural logarithms. But what about other bases? Enter the change of base formula. This handy equation allows us to evaluate logarithms of any base using just our calculator's existing functions. For simplicity, we often use the base 10 formula. It's a straightforward approach that fits well with the typical calculator setup. Let's see it in action with an example. Consider the expression log for 25. By applying our change of base formula, we can actually calculate this using a standard calculator. After crunching the numbers, we find that log for 25 simplifies to approximately 2.23. It's that simple to transition between logarithmic bases. Moving on to the broader properties of logarithms, these rules help us manipulate and understand logarithmic expressions in depth. For instance, we can use these properties to express complex logarithms in terms of simpler ones. Take ln6, which can be broken down into ln2 plus ln3. These transformations are more than just mathematical tricks, they simplify calculations and help us solve real-world problems efficiently. Now, let's explore how these properties assist in rewriting logarithmic expressions. This skill is crucial for algebra, making complicated operations much more manageable. Consider the expression log 5x cubed y. Using our properties, we can expand this to log 5 plus 3 log x plus log y. Each term now stands alone, simplified and clear. This expansion shows the power of understanding logarithmic properties in practical applications. But what about reversing the process? Yes, the properties of logarithms also allow us to condense expressions. Take for example log 10x plus 3 log 10, x plus 1. By applying the properties correctly, we can condense this expression significantly. The result? A much simpler expression, which in practice helps in calculations where space and clarity are at a premium. Lastly, let's not forget that these techniques aren't just academic. They are essential for modeling real-life phenomena where logarithms play a key role. So, whether expanding or condensing, evaluating or rewriting, the properties of logarithms are powerful tools in both theoretical and applied mathematics. Keep these techniques in your arsenal, and you'll handle logarithmic challenges with ease.